here series, and I'm going to put over here parallel. Okay. I didn't sketch them in what it looks like as the schematics. If I did, I would have sketched a series circuit as, when you get into the schematics, it looks something like this, where this is, let me call that point A, let me call this point B, this is resistor 1, that's resistor 2. My voltage across points A, B. For parallel, this would be point A, it splits. B, this would be resistor 1, this would be resistor 2, this would be my voltage from A to B. In a series circuit, what we showed, if this is my overall voltage from A to B, this overall voltage is equal to the voltage that's lost or used in resistor 1 and the voltage used in resistor 2. What we saw for the parallel is that the voltage across this entire branch, it doesn't matter. If I'm at point A and between point A and B, I use a certain amount of voltage. Whether I go through resistor 1 or I go through resistor 2, that voltage is going to be used. So the voltage across each branch in a parallel circuit is the same. With a series circuit, when we looked at the current, the speed that the bucket was going through at point A is equal to the same speed that it's going through resistor 1 and through resistor 2 and at the end of the line through point B. The current is going to be the same. There's not going to be gaps. There's not going to be traffic jams in this circuit. The current through a series resistors, through resistors in series, the current through each resistor is going to be the same. Unlike a parallel, my current at point A is going to get split between resistor 1 and the current that goes through resistor 2, and then it rejoins afterwards, and that's going to be the same as my current through resistor, or at my current at point B. We talked about we can get the total resistance here by simply adding up resistor 1 and resistor 2. So my total resistance in a series circuit is just the sum, adding up all my resistors. My total resistance in a parallel circuit, it's the reciprocal, it's a sum of the reciprocal of my two resistors. And so, okay, last part to kind of consider. One thing to keep in mind with a series resistance, with a series circuit, is that my total resistance in a series circuit is always going to be bigger than R1 or R2 since I'm adding them up. That's kind of an obvious statement. And the reason I'm bringing this up is that in a parallel circuit, it's just the opposite, that my total resistance is going to be less than resistor 1 or resistor 2. So for example, if resistor 1 is 5 ohms, resistor 2 is 10 ohms, my overall resistance has to be less than 5 ohms. And that's a good way to check to make sure you're doing the math. As a final point of clarification, I tend to say total resistance. A lot of people say equivalent resistance. I mean this to be the same thing. Some people do differentiate between total and equivalent resistance, and I apologize if there's any confusion in that. I just tend to use them as the same. So that's a kind of a summary between differences of series and parallel circuits. I hope you got some value out of that. So there you go. Thank you. Good luck.